Hey guys, welcome to, I think it's part 5 of the West Coast Drivetrain series. Today we're going to be making the belly pan on our drivetrain. And so if you guys don't know what that is, a belly pan is basically going to be the big plate that goes on the underside of the drivetrain. It connects all the pieces of VersaFrame. It's like one giant gusset. And then the more important use for it is that you can use it to mount electronics to your base, and it usually has like a crisscross pattern on it, which makes it really easy to zip tie wires down. So let's just take a quick example of that, I believe. Yeah. So this one of, I think it's their 2015 robot. Great example of how to make a really effective belly pan, or like make use of a belly pan. You can clearly see that all these wires are zip tied down to like the crosses on the belly pan. Makes for like really clean wiring in general. Let's go look at another team. Of course, 254, great team. You can see, yeah, just another example of how you can use a belly pan. Over here we have a more simplistic belly pan. No crosses. I don't know what the technical term for that is. I don't know, fence pattern? Whatever you want to call it. There's no pocketing on this belly pan, but as you can see, the wiring is still pretty clean, and I think they did that by drilling holes into the belly pan and then running the zip ties through there. So that's the general purpose behind the belly pan. Other teams, they do like doing electronics on the side, which is something that we did last year. It made it really easy to access, but we're going to be focusing on the belly pan that goes on the drivetrain. Oh yeah, teams sometimes like to do this, like a really compact electronics thing. I don't know how I really feel about this, because I feel like it's really hard to access the motor controllers when you're trying to test the motors on your robot. I don't know. That's just a personal preference. But let's go ahead and go back to this CAD. Alright, to start off, I'm going to hide this bumper that we did from the last episode. Okay, and now let's start a new part. Oh. Okay, so the first thing we want to do is take a look at the dimensions of the bottom. Oh, looks like I hid this bottom piece. Is it this one? Let me just undo real quick. Let's hide this one. Okay. Let's create a new part. Yes, so let's start a 2D sketch on the XY plane. And we're going to start off by measuring the distance between faces to see how big our belly pan needs to be. I think it's going to be 24 by 16. Most likely 24 by 16. Alright, that looks good. So let's start with a rectangle that's 24 by 16. Let's go 16 and then 24. And then, in order to mount it to the frame of our drivetrain, we're going to make use of the holes that run around a VersaFrame like this, right? So let's start off by offsetting by 1 inch, because that's how thick our VersaFrame is. And we can go ahead and pattern the holes around here. So VersaFrame comes with 0.163 holes, but on our team we drill them out to 3/16, so that's what I'm going to do. 3/16 is not clearance, it's just the same diameter as a 1032 bolt. So let's offset this exactly how the VersaFrame is offset. And if you guys don't know where I'm getting these numbers from, you can either look at the, measure it from here, or you can just go on VexPro's website and see the dimensions of VersaFrame. Anyways, we're just going to quickly pattern these across the drivetrain. So 16. And now let's do direction. Flip the direction, make that 24. Okay. Now, just to do a quick recap, I'm going to use the mirror tool. So to use the mirror tool, you're going to start by making a line segment that's going to act as the line you reflect everything over. Make sure it's in construction, because this is not part of your final product. Alright, let's mirror these holes. Oh yeah, it works. Oh, I accidentally selected the line itself to be mirrored. If you make that mistake, just hold shift and then click the line again, I think. Yeah. Alright, now mirror line will be the center one. If it wants to let me select it. Oh, okay, looks like I already did select it. Anyways, let's do the same thing on the other side. Let's start here, highlight all of this, mirror line, click this, apply, done. Okay, now let's extrude this. Why the heck is that a hexagon? Why are these all hexagons? What did I do wrong here? Okay, I guess it just looked like they were hexagons. I don't know what really happened right there. But, okay, I guess they're still circles. So let's extrude this. Some teams used to use 16-inch metal. Some teams use 1/8 inch. So I think the general rule is that if you do 16th inch metal, you're going to have like really thick cross braces, and I don't want to do that. So I'm just going to do 1/8 inch thick metal, which will also be good in terms of holding together the frame. I think 1/8 inch was like a pretty good thickness to make sure that everything stays together. Okay. Now the next thing we want to do is create like the actual cross braces, right? So let's start another 2D sketch. And the first thing we're going to do is project geometry, right? Okay. So we basically need to decide how many cross braces do we want to go across and how many cross braces do we want to go down. I honestly am just going to do, let's see, we can probably do like 8 across this way and 10 down. I think that sounds good. So I do want to know the dimensions of the inside. It's just 22 and 14. But just to show you guys what that looks like, I'll set them up here. Now we're going to start by making like a template of one cross brace in the corner. And that's going to start by making a construction box. And so that's just going to be, what do we want? We basically are going to take the length of the inside and then divide it by the number of cross braces we want. So let's do 14 divided by 8 because we want 8 cross braces along the inside. And then for the other one, we'll just do 22 divided by 10. Okay. I actually think we can go... No, those look like pretty nice numbers. I was going to go a bit bigger. You guys can... you can mess with it however you want, but I think I like this. So next thing we're going to do is create the actual crosses. And that's by staying construction. We're going to go from corner to corner. Right, really simple. And the last step is really just doing the same thing that we did in the other episode with pocketing and doing this 3-point center style design. And then let's do 0.2. Oops, it looks like I'm still in construction, so I'll just undo that, get rid of construction, and then do that one more time. Okay, and let's do it in the other one. Cool. So I don't have to pattern this inside here. I'm going to finish the sketch and then pattern it externally. Just because it doesn't, it just makes more sense. Because if you pattern this in here and then try to extrude it, you're going to have to click each individual cross brace. But if you extrude one and then pattern the extrusion, it just saves a lot of time. Right? So let's do this one. Okay. Now, you can see that it's going, I want to teach you guys another tool here. You can see it's going above the belly pan that we've already made, right? So what we're going to do is we're going to tell that Inventor that instead of going 1/8 of an inch, we're going to do 2 a certain distance. So if you hover over this, it says 2, right? We're going to say we want to go to the bottom face of the belly pan. And now let me show you why this is important. Let's say okay. So that means if we edit this extrusion here, and let's say I just want to change it to 1/16 of an inch, that second extrusion will automatically update, right? And that just makes stuff really easy. Okay, now as you can see, there's a gap here. in this corner here, and this corner here. But I'm pretty sure it should be filled after repattern it. I think it should work out. If not, we can just go back into Sketch and edit it. It's been a while since I've done this. So the feature we want to rectangular pattern is going to be the X, of course. The direction we're going to choose is across. Now the first thing it's asking is the number of times we want to do it. Earlier we said we want to do 8. And the second one is asking the distance, which is going to be 14 divided by 8. Right? And you can see it just fits perfect. And direction 2 is going to be this edge going not that way. So let's flip that. We want 10. And then I believe it was 22 divided by 10. Okay. Now you can see that all of the crosses overlap, and it should make for a clean belly pan. Okay, now let's do the little more time consuming or CPU or GPU, I don't know how computers work, whatever computer intensive process that this is about to do. We're going to be filleting every single inside curve, because as you might remember from the pocketing video, a CNC router cannot cut perfect edges. Maybe if you have a water jet, but a CNC router definitely cannot. So just to illustrate that real quick, let's do a sketch on here. The bit we use on our CNC is a 3/16 bit. So if I have a 3/16 bit that's this big, you can clearly see how it won't be able to get into this corner, right? The most it can do is its radius, so from here to here, which would be 3/32. So that's the size fillet we can create. So all I'm going to do is hit this inside edge, right? That's 1/8 inch. But I want to do the absolute minimum, which is going to be 3/32. So not much difference, but it's still better than 1/8. Now, this is where it gets kind of crazy. We're just going to hit all fillets, and then hopefully Inventor doesn't die and it actually executes all the fillets. So we'll see what happens. Alright. Oh wow, look at that. It looks like it did all of them pretty fast. Much faster than I expected, to be honest. And then let's hit apply. Okay, I think applying is the part that takes a bit longer. And of course you might notice that I missed the fillets in the corners. I'm going to get to those in a second. So while this loads, let's talk about the next step. Next step I want to do is not only mount this belly pan to the drivetrain, we need to start cutting holes for things that already mount to the drivetrain, such as the bearing blocks and the gearboxes. So the gearboxes, once I switch over to the other tab, you will be able to clearly see that they stick through the belly pan, as well as the West Coast Drive bearing blocks. Alright. It looks like all those fillets worked out. And now I want to go ahead and hit the fillets in the corner. I actually think I might make these an 1/8 inch fillet just so it looks nice. Yeah, let's go ahead and make this 1/8. Okay. And now, before we move on, I'm going to quickly save this just to make sure we don't miss anything. Or we don't lose anything, sorry. Let's just save that. Actually, you know what? I'll just save this belly pan. V1. Alright. And now we're going to import this into the assembly, and you'll be able to clearly see how a lot of it just won't work in its current state, and that's going to be the next step, editing it to make everything fit. Go ahead, right click, rotate, escape, let's start constraining. The first thing I'm going to do is constrain to these holes. So obviously this is one of the corner holes. And then I can pick any other set of holes. I think I'm just going to pick the next closest one, because it's very easy. And then we can just do a face-to-face constraint. I'll lift that up. A mate constraint will go from this face to this face. Okay, cool. Now, the next thing I want to address is this problem. So, as you can see, the bearing blocks are going inside the belly pan, which is obviously a very big problem. The second problem is that the gearbox is going through the belly pan, which is obviously another big problem. So those are the next two things we need to address. The first thing we're going to do is the bearing blocks. Now, I'm going to be completely honest. The method I use to cut all the holes that go into the belly pan is pretty much like guess and check, because I don't know. I mean, I could measure how far away this is from here, but to be completely honest, I found it to be a lot faster to just guess. So I mean, let's just get like a rough estimate, I guess. 3.5 inches. Okay, so I need to know that the rectangle that I cut out needs, the center of it needs to be 3.5 inches from the bottom edge. So I mean, I guess that kind of helps. So let's start a sketch. The first thing I'm going to do is cut out my shape, and it's going to go 3.5 inches. Oh, that's not what I want. So the width is just going to be 1 inch for now, and then I can make the height of it like 2 inches. I don't know. Let's measure that real quick. So as you can see, it's not like a very cut and dry method. I'm just like kind of guessing and checking to see how this works. Okay, let's do 2.5, I guess. 2.5 inches. Let's draw a center line from here to here. Construction, because we don't really care about it. And then we can center it 3.5 inches away from here. Alright, so I'm just going to do one for now just to test it and see what it looks like. Again, let's use the 2 tool. So 2, and I want it to cut to the other face, right? Okay. Let's take a look at what happened. Let's see, what side did it cut? It looks like it cut the wrong side, actually. So, let's go ahead and flip that. We're just going to open up our extrusion. Let's turn it around. All we have to do is delete this 3.5 and then make the 3.5 away from this face, right? Okay, now let's try again. Let's save that real quick and take a look at what we have. Okay, as you can see, I clearly messed up the distance. I'm actually really I didn't select the center point of the line, I selected the bottom face. So yeah, that was the problem. I selected the bottom edge. So let's delete that and go from the center line, 3.5. Finish sketch. Okay, now it looks like the only thing that's particularly an issue is going to be this cross brace area here and this cross brace area here. So all we really have to do is extend this rectangle out more, which is actually good because that will also allow us to create a more rigid frame, and I'll show you why in just a second. So instead of 1 inch, let's go 1.5 inches. Okay, nice, that extended right into the frame. Finish that. Go back here, and it looks a lot more safe, right? I don't like that it's cutting into here like that. There's absolutely no reason to. So I'm just going to go back and edit this so it doesn't cut into that corner. Okay, so instead of saying it should be 1.5, what I can instead do is project geometry of this line, hit escape, and use the coincidence constraint to say that I want this point, that white point, to be fixed to this line, and hit escape. Sorry, throat's a bit dry. Okay, that looks a lot better. I'm gonna get to making like the actual like sturdy frame around it in just a second, but as you can see that this also like allows for a good amount of space. Remember, the point of a bearing block is to slide. It allows like some space for it to like go back and forth, right? And that's one of the main reasons we have the bearing block in the first place. And the number we selected should allow for enough movement. Okay, that looks pretty good. The next thing I'm going to do is basically do the middle wheel, right? And then we're just going to mirror that over to the other side to these wheels. So let's do that again. Let's just measure like how far away it is from the bottom face. Let's see, let's pick like a rough center point. Right there. And let's do, what are we doing? The bottom edge? Yeah. Okay, so 12 inches, right? Well, it says 12.05, but it's like 12 inches. So let's do that again. Go back to our sketch. We're just creating the same thing again, right? So we're going to do, let's just stick for 1 inch for now, and then we can edit it later. We're going to do, what, 2.4-ish inches? I'll keep 2.5 for now. Inches, and then that should be good. We're going to create a center line real quick in between, God, slide this over real quick. In between these two lines so we can like actually dimension it away from the edge. Hello, can you please let me select it? Would appreciate it, thanks. Okay, this is interesting. I don't know why it's doing this. 1.209. Okay, that's wrong. That's completely wrong. Okay, I'm gonna have to do this manually. I thought I could use like the quick select tools or like the little green dot that automatically locks in stuff, but I guess it doesn't want to do that. Let's see, 2.5. Yeah, there you go. Okay, now we can slide the whole thing. How many inches was it? 12 inches, I think. Yeah, 12 inches. Let's do 12 inches. Okay. And then to select the actual profile, we just double click on extrusion. Okay, and then we go back to profile. Come on. Come on. Let me select profile. Oh, sorry. I guess I already selected it. Okay, that looks pretty cool. Let's make sure it lines up, and then we can move on to like widening it. Okay, cool. It lines up. Now let's just move it out similar to what we did in the other one. So I'm going to delete this width that we have here, and then project geometry of this inside curve, and then I'm just going to make that coincidence constraint. Oh, not that. Sorry, I keep having to drink water. But yeah, that should be good enough. And then if this looks good, which it does, what we're gonna do is extend or like mirror this to the other side, right? And once it's mirrored to the other side, we can go ahead and create a frame around this so it doesn't look like it's just cut off randomly. One thing I find actually kind of interesting is that, it looks like this is, yeah, it's definitely longer, which is interesting. So this one is about 1.429 inches. And you know what, instead of doing coincidence constraint, you're actually going to delete that and then just make it the same dimension, because we don't need to make it coincidence constraint. Yeah, this will work just fine. And it'll be a lot more symmetrical, right? Yeah, that looks a lot better. So now let's go back to our sketch and then just mirror this whole thing to the other side. And you guys obviously know how to do that. So I'm just going to go through that real quick. Hit escape, mirror. Let's go ahead and mirror all of this. And then we just have to actually select those profiles. So profiles, select, hit OK, and then let's check on these. Yep, they look good. Go back to our assembly, make sure they look good. Okay, everything seems to be in order. Now, like the slightly harder part is going to be actually creating the frame that goes around this. I'm going to show you how to do it for just one of these real quick. So all we're trying to do is create support for this whole structure here, right? So literally all I'm going to do is first I'm going to hit project geometry, and I'm going to project the whole thing, right? So just so I can like actually edit it. Wow, that's taking a lot longer than expected. Now, I don't know how to explain this process, so I'm just going to show you. I feel like a lot of this is guess and check. but I don't know, maybe I'm just bad. So I'm just creating rectangles to go around this, but I'm only defining the width of the rectangles. So that's a little problemo. Let's delete that coincidence constraint just so I can extend this. I know that these two have to be in line with each other, right? So let's just go ahead and connect them with the construction line. And then just say that all of these lines are parallel to each other. It's probably a faster way to do this now that I think about it. God, come on. Oh, my bad. I meant to say vertical line. Yeah, there we go. And now these are all moving together. Okay, now all we have to do is add final rectangular piece that is also going to be 0.2 inches wide. Yep. And then let's take out the construction on that. Oops. Take the construction out on that. Come on. Alright. And now what we're going to do is set it up so this line is going to be like on the border of this. Okay, so if you can like sort of imagine this, if I extrude this, I've now created like a more rigid frame around to go around this whole thing. And now the reason this process is kind of random is that you're going to get like a lot of corners like here, or like small gaps like this that you just have to remove manually. You can't like fillet them out or something. You just have to manually cut them out. So what I'm going to do is connect this with the line here from here to here. Oh, I'm still in construction, so let's get rid of that. Connect these two with the line. And now I should be able to just trim these off. Or not. Okay, what I'm going to do is delete the dimensions. And now I should be able to trim these off. Okay, that looks pretty good. So stuff like this, all you really have to do is go over the parts you want to keep. So I'm just going to go over this whole segment here. Let's do an arc real quick. Where does it go to? Oh my god, Inventor is being very laggy. Okay, now let's do a line from here to here. And so the reason I'm doing this is because I don't want this to be a hole. I want this like whole region to be filled in. And then we can take care of the rest of it just by making this construction. So since this line is construction, it obviously won't be able to extrude the rest of it, if that makes any sense. I don't know. And so let's just repeat the process for the other holes. And then I'm just going to do this for one of the bearing block pieces because I feel like this is pretty self-explanatory. And I'm just going to be wasting a lot of the video if I just do this for every single piece. Okay, and then let's hit them with the line here. And then we can make this construction just so it doesn't accidentally extrude like this whole diamond plate, right? It just does this area. And then over here, to be honest, I think we can keep the sharp edge, and then once this is filleted down into a curve, it should look okay. I don't know. We'll just guess and see. So it's going to ask me to select some profiles. It's basically right now it's trying to like select all of these little diamonds, which is why it's taking so long. Yep. But all I really want is like this rectangular frame right here, which I'm going to give it a second to load. Okay. So we can do this, obviously. Oh, before I move on, I'm going to do a quick 2. So it doesn't try to extrude it in an inch. Go back to profile. Let's do this rectangle. Let's do this rectangle. This little triangle. So you can see I'm just picking all the little things that I went over earlier. Yeah. See, that automatically got filled in. See, since I cut this off here, it doesn't override into there. So I also want this taken out actually. And then I'm just gonna hit OK. Hopefully, crossing my fingers, this works. Let's see. And then hopefully, okay. So I'm gonna go back before I move on with the fillets. I'm just gonna go back and make sure it looks okay. Yeah, that actually looks really good. So it doesn't look like the bearing box can slide too much in its current state, but we can obviously adjust that very easily, which I'm not going to waste time doing right now. But let's go ahead and hit it with some fillets. And then once we give it some fillets, what we can actually do is mirror what we have done here onto the other side. So I'll show you how to do that in just a second. So right now it's doing 1/8 inch fillets. I'm going to change it to 3/32. Okay, it looks like I got everything, and now I'm just going to change to 3/32, and it should be good to go. You know what, that actually looks a lot better than I expected. So if we go back and take a look at it, damn, that looks pretty good. So let's go ahead and save this. And now, I won't repeat the process for this middle section, but I'll show you how to mirror what you've done here onto the other side. So what we want to do is essentially mirror a whole 3D feature, which requires a mid-plane. So what we're going to do is go to the drop down and just create a mid-plane between two planes. And so a plane includes a face, right? So we're just going to click the face here and the face on the other side. Now it's created a plane perfectly in the middle, and that's going to allow us to mirror the features. So let's go, where's mirror? Mirror. The features we want to mirror is the last extrusion we did and the fillet, right? And then the mirror plane is just going to be this work plane. And then we go ahead and hit OK. Crossing my fingers, it all works okay. I guess it did okay. I'm not sure why the fillets didn't go over, to be honest. Let's look at what it did. I don't know. It didn't do the fillets for some reason. I have no idea why. Say okay. If it didn't do the fillets, that's okay. We can just do it manually. I mean, it's not a big deal. I'm pretty sure it's something trivial that I missed. That, I don't know. If you can correct me, please do. That looks good. And then we're just going to get this fillet in here, and then here. I think that should be the last one. Hit apply. Alright, there we go. So now both sides look the same. Oh, looks like I missed a fillet here. If you miss a fillet, all you have to do is double click on the fillet over here, and then you can just click on the fillet that you missed. Click OK. Cool. So let's go ahead and save that. Go back to our assembly. Okay, that looks really, really good. You guys can take care of this middle one. It's the exact same process, right? Just slightly different shape. It's really arbitrary. You can see that I just picked whatever looked good. I took out what I didn't want, and I just threw in shapes that I thought would make it look better. It's really random, to be honest, this whole Bellypan process. So there's two things left. We need to cut out a hole for a gearbox, and then I also want to show you guys how to actually create holes for electronics to mount to, because here, just looking at a quick example, you can see that actually that's not very helpful. Let's take a look here. Yeah, so you can see that there are actually holes in the Bellypan in order to mount the electronics, as you can see on like the PDP here, right? And so that's what I want to show you guys. So going back to Inventor, let's just create a slot for this gearbox. So it's the same exact process as before, with like the hole cutout and the rectangular like border that we created around it. It's just for the gearbox. So since it's the gearbox, I can either create a rectangle cutout that's like here, right? Sorry if my mouse is making all the parts flash, but basically here, or what I actually like to do is start from the corner and pull out a rectangular box till the end of the gearbox, and that just makes it a lot easier to install the gearbox. It makes it a lot easier to slide in, if that makes any sense. But let's go ahead and do that. We're going to start by doing a 2D sketch on the Bellypan. We don't need to project geometry of the whole thing, just the edges we need to manipulate. So let's do this edge, the top edge, and this edge, right? And so that's going to allow us it auto aligns the rectangle up to these two edges, and now I want a rectangle in some dimension, right? So again, this is all very guess and check. The one thing we can measure, I guess, is the plate. So let's do that. I'm going to go to the inside of the VersaFrame. So 2.17 inches. Let's do 2.5. I don't want to do 2.25 just because it's a bit too close and it makes it really hard to install. So let's do 2.5 inches. Okay, as you can see that this rectangle is a free floater. It doesn't really want to lock onto anything. So before we move on, let's just use the coincidence constraint and lock that center point of these lines to like the whole line of the rectangle we're working on. Okay. There we go. Next thing we need to choose is the height. Again, this is very, very arbitrary. I would just like to pick like a nice whole number. So let's choose the bottom edge here. And let's shoot for, I don't know, like right there-ish, I guess. 5.44. Let's try. We can go under the 5 inches, I guess. Just for aesthetic purposes, actually, you know what? I'm going to show you guys how to use the driven dimension tool. So what you're going to do is create a dimension, right, and just click check. Now hit escape to clear this. Right click and say driven dimension. Now this dimension is driven by anything you do. So if I move this around, this number will automatically update. So the number that we had earlier, what was it, like 5.4? So I know I'm in this general range, but just to make it look a lot better, what I can actually do is just tell it to cut off like, what, halfway here? Yeah, I think this will actually make for a really good look. And then, since I guess there's no significant difference between like here and this point here, I could make it tangent, possibly. No, I think I'll leave it the way it is. Again, this is just all random, arbitrary, it's just aesthetics. It really does not matter what you do. So, as you can see, I hit 5.5. I want to decrease it. I think that's a bit overkill. Let's do like right here. What, 4 point, what is that? 4.4? I don't know. Forget the number. Let's just do it like exactly halfway. We're going to do project geometry, that curve, and now hit escape and use the coincidence constraint to make that point on that line. Okay, cool. Now we can extrude this, right? Okay. And if you go back to our West Coast assembly, you can see that the gearbox clears it really well. Or the cutout clears the gearbox really well. I don't know, something like that, right? And now we're just going to repeat the process for creating the rectangular frame around here. So let's start another 2D sketch on here. Quickly project geometry of the whole thing. I mean, we could project geometry of individual parts, but honestly, it's just a lot, and I might as well just project geometry of the whole thing. Okay, so let's create a rectangle that's going to run from here down to here-ish. Oh, this line right here, right? And then I want it 0.2 inches wide. And I don't know how long I want it yet. I just know I want it 0.2 inches wide. Okay, cool. Now let's pull this back inside. Pull this back inside. And we can just use the coincidence constraints to pull everything together. So let's do here to here. And then we can just do here and here. Right. And then the next thing we're going to do is go through, and remember all those like little corners and stuff that were sticking out on this end? Just go through and make sure there's none of that. If there is, you can edit it real quick. And it looks like I'm actually like pretty like in the clear. Like it doesn't look like there's anything sticking out. So let's go ahead and extrude this. Okay, give it time to load. God, I need to figure out how to make this run faster. But all I want to do is select these shapes, right? Right now it's going to an inch, so I'm just going to change this to the 2 feature. I'm going to go to the bottom face of this. Go back to profile. What am I selecting? I'm selecting this whole rectangle here, this whole rectangle here. That's it. And then hit OK. Right. And then the next thing I'm going to do, I'm going to hit it with a few fillets, and we should be able to move on to the next step. Alright, let's hit it here. I'm just going to manually go ahead and select all of these. If you guys have a water jet, you probably don't need to do this, but I think it just aesthetically makes it a lot more appealing. That's redundant. It makes it a lot more aesthetic, right? I don't know, that's just me though. If you got wire EDM or some cool water jet, I guess you don't have to worry about this. Apply. There you go. Save this boy. And then before I mirror it to the other side, I'm just going to go ahead and check to make sure everything looks good. Yeah, it actually looks really good. This is flush up against the bumper, sorry, not the bumper, the belly pan. And it clears everything pretty well. You could pull in this side, you could pull in this side if you want, but does it really matter? Like, would you have mounted something in this corner? Probably not, right? So you might as well just save some weight and cut out some more metal here. Honestly, it does not make that big of a difference. Let's mirror this. Mirror these features. What am I mirroring? I'm mirroring this extrusion, and this fillet. And then I'm just mirroring it to the other side. Hopefully this time the fillets like actually mirror and I don't have to go through it again. If they don't mirror, I'm not going through it again. You guys can do the fillets yourself. It's not that bad. I don't have to show you how to do it in this video. Yeah, it didn't do all the fillets. I don't know why. Okay, whatever. You guys know how to do that. We're moving on. Let's save this real quick. And then the next thing we're going to do is mounting electronics. I'm just going to show you one electronic piece. And then from there you should be able to take care of the rest. So the one I'm going to show you guys is the power distribution panel, which is this middle piece right here. So let's go ahead. We can either go to GrabCAD or I think AnyMark has it. Oh, sorry about that. But I think AnyMark sells the PDP. I think it might also be Vex. Here, let's try Vex. I hate AnyMark, so if Vex has it, I don't have to worry about it. It's just, I don't know, AnyMark makes it so hard to find CAD on their website. You have to like go through their whole catalog or something. I don't even know. Oh, okay, thank God. Vex has it, so we don't have to deal with AnyMark. Thank God. Just go ahead to the CAD file, power distribution panel, preview. Okay, that looks good. And so, I don't really need the CAD to actually make the holes I'm about to make to mount the power distribution panel, but I'm going to download it just for the sake of showing you guys like what it looks like mounted to the robot. So for now, what I'm going to do is take a look at the drawing. Okay, so what do we really care about? Oh, can I open up this picture? Okay, what we really care about is where these holes are in the corners, because that's where we get to put our bolts to mount, right? These are the numbers that we care about. We care about 4.11 inches because that defines how far apart these holes are on the width, and then 7.176 inches because that defines how far away they are in length. And then they're telling you it's a number 10 clearance hole, so we can just do like our standard 3/16, right? So going back here, let's go ahead and start a 2D sketch on here. So generally what you do is model all of your electronics to figure out their layout. So that means I would basically take a rectangle here, right? How big is the PDP? The PDP is what? 7.586. Let's do 7.6 by 4.52. Let's do 4.55. So 7.6 by 4.55. Let's do 4.55. And then we can do 7.6 right here. Oh wow, it was actually pretty close. Okay, so this would be representing our PDP, and then maybe we have like some talons laying around here. If you guys don't know what talons is, or just look them up. I'm not going to go over electronics in this video. That's for another time. I probably won't even go over it in this channel, but let's say we got some talons laying around here. I'm probably going to rectangular pattern them like this. alongside here. You know, something like that. I think you guys get the general idea of what I'm doing. I'm just laying out all the electronics I want on my robot, right? But just for the purposes of this video, I'm just going to show you how to do the PDP, and then from there you should be able to figure out how to do everything else. So the first thing we're going to do is center the PDP along your whole belly pan, right? So let's project geometry of these two sides, and that's going to allow us to create a line in construction that runs from one side to the other. And then we can just center everything on this line. Hit escape. Give Inventor a second to load, and then we're just going to align all of these little pieces. Okay, now it just wants to slide up and down. So after laying out my supposed pieces, maybe I decide that I want my PDP to be 6.5 inches away from the edge. You know, just some arbitrary number. It does not really matter. But this border is not part of my final product. This is only representing my PDP. What is going to be in like the final product are the holes that mount the PDP, right? So that means we can make all of this construction. We don't really care about it. What we care about are the holes. So what we're going to do is next create this 4-hole pattern. We know it's a 3/16 hole, so let's start with that. And then it's in construction. Let's get rid of that. Okay, let's go ahead and quickly make 4 holes. Not 2/16, 3/16. God, I'm getting rusty with my CAD skills. But we got 4.11 for the distance between these two holes, and then 7.176. These numbers we obviously cannot round because they're the distance between the holes. So let's make this real quick. 4.11. And then let's do 4.11. And then what was it? 7.176? Okay. 7.176? Yeah, like that. And then right now these holes are not completely aligned, so we can do that real quick. Why are they at an angle? I didn't even know this was possible. So you saw, just to fix that, I just clicked the hole again, and then we just do 7.176. Okay, and now these are not aligned. All we have to do to align them is just connect them with the line. That's in construction, because we don't care about it's not part of the final product. And then we connect it like this. And then we'll just tell Inventor I want these lines to be perfectly, vertical? Yeah, vertical. Yeah. Or not. Something is amiss here. Something is definitely not right. Do I need to make these ones horizontal? God, I messed something up. As you can see, the CAD process is wonderfully iterative. And I have absolutely no idea what's going on, so we're just going to delete these lines and try again. I definitely made the mistake here. Cannot blame Inventor on this one. But let's just try this one more time, and hopefully it works out. Let's just do one line at a time. Make this, vertical? Yeah, let's go. That works. And then, I don't think I even have to worry about the side, do I? Yeah, I do. Connect these, and then make these, horizontal? Yeah. Okay, there we go. I don't even have to mess with this one, because these are all fixed. So now, all we have to do is dimension them into the corner of this PDP, just like they show in the drawing. And so, instead of trying to dimension, subtract the number and trying to figure out what's going on, all we have to really do is center it, right? So we can find the center point on this line, which should be right there. Connect it to the center point here. God, I cannot even see my screen. Somewhere along here is the center point, right? Okay, we'll figure out the center point in just a second. Let's put it on this line. The center point is just going to be half this width. What is the width? What did I do here? God, where are my numbers? 7.6, right? So I just have to say that tip of the line, escape real quick. The tip of the line is going to be 7 point halfway, right? So 7.6 divided by 2. Let's just do that. 7.6 divided by 2. God, I don't even know what I'm doing today. Okay, that seems to work, question mark. Not really sure why this line's diagonal, to be honest. Yeah, okay. So these holes are still moving, which is kind of interesting, to be honest. Not sure why. We'll just make this line horizontal. And that should center it. Yeah, it looks centered. And then we can just do the same thing on the other side. Hopefully this time, it'll do it in like automatically, crossing my fingers. So we'll go from here to there, and tell Inventor to make that line vertical. Hit escape. Oh, I keep hitting the help button. There you go. So now we have our full 4 holes lined up the way we want, right? The next step is obviously that these need to be cut extrude, but you might see that there's a problem with this. This hole cannot be cut extrude. This hole cannot be cut extrude because it's already in the air. So what we're gonna do is we're gonna do a normal extrusion and then do the cut extrude later. You'll see what I'm saying in just a second. So what we're gonna do is we're gonna offset this by, let's do what, 1/4 inch? Yep, that sounds good. Not construction. God, I need to pay attention to this more. Not construction. This is 0.25. This is 0.25 here. 0.25. God, I don't even know what I'm doing today. I think I'm just sleep deprived. But you can see that now that we've offset it, these things actually overlap on the frame that we made. So these holes will actually be usable. So let's do a quick extrude with these holes. And then we're obviously not going to go 1 inch. I'm going to start by doing the 2 thing. And just going to go to that face. Oh, not a cut extrude. So let's just change that back to a normal extrude, please. Click profile, because I want that thing. This thing. And then this circle. Okay. All we have to do is cut these holes back out and then fillet the corners, right? So let's start by cutting the holes back out. These holes are okay, but these are obviously not. So we're just going to quickly project geometry of the curve, right? Make a circle from the center to the edge, and then circle from center to edge here. Hit escape, finish sketch, and now we can cut extrude this. Okay, should be good. Now the next part is going to be filleting, which we've gone over many times, but I'm going to go over it just one more time. This edge right here. But yeah, that's going to be basically it for the rest of this video. Just filleting out all of these corners. But yeah, that's it for the belly pan. You need to make holes to clear the bearing blocks in the gearbox, and then you also need to make these holes in order to mount electronics. And that's basically the premise of the whole belly pan, right? It holds your drivetrain together and it gives you various mounting points. Now the next video, I really don't know what direction I'm heading in. I might go over elevators, ball mechanisms, stuff like that. I really don't know yet. So if you guys have anything you want me to CAD, please definitely let me know and I will get to that. One of the things you'll notice is that when you fill it is that you do get some sharp corners remain, and you do need to pay attention to that because the CNC cannot get inside there. So what we're going to do is we're going to fillet this, and now you can see that it's created yet another sharp edge. So you could keep filleting this, but the other option, which I actually like a lot more, is that if you do a 2D sketch on here, let's project geometry of the area of issue here and here. Now imagine you have a CNC bit that's 3/16, right? That CNC bit can only come in to where it's tangent to the edges you want to keep. So we can just do that like this. And now we want it to fill in this whole area, right? So we can, project geometry of the inside curves like this. And then we can trim this out here. And now we can fill in this whole gap. So let's go to the other side. We'll do it 2 again. Oh my god. And we'll just head over to this face, right? And then just hit OK. And see, that's a lot less effort than trying to fill out the same corner over and over again. But everything else looks pretty good, to be honest. I think, yeah, this has another issue here. Let's just add on to this real quick. Shouldn't take too long. All you have to do is project geometry of the curves that are a problem, right? And then create your CNC bit, which is 3/16. Hit escape, and then make it tangent to the edges that it can actually go into. And then hit escape and trim off this leftover. So hit escape. Double click on the extrusion so we can adjust the profile. Click profile up here. That's going to be the next profile. Hit OK. There you go. Manual fillet. Beautiful. So those are going to be the mounting holes for the PDP, right? We can go ahead and save that. That's going to be it for this video. As you can see, we've created clearance holes for the gearbox and bearing blocks, as well as mounting holes for the electronics. You guys can take care of the rest of it, I believe, like the frame that goes around this bearing block, as well as the mounting holes for the other electronics. It shouldn't be that difficult, but of course, if you guys have any questions, please leave a comment and I will be sure to get to that. Alright, thank you guys so much.